This is our lesson on scientific notation, but we're going to start off with exponents. Scientists use exponents to condense very large or very small numbers. So we've got the Earth is more than 100 million kilometers from the sun. We can write that large number using powers of 10. Remember, we talked about this with exponents. That means we have a base and an exponent. So we have all these tens, 10 to the 8th, because we have 8 tens. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. All right, and this one should not be there. So it is 10 to the 8th power. This is a power of 10 right here, 10 to the 8th. So the table below shows several powers of 10. 10 to the first is 10, its value is 10. 10 squared is 10 times 10, which is 100. 10 to the third is 10 times 10 times 10, which is 1,000. And 10 to the fourth is 10 times 10 times 10 times 10, which is 10,000. So you can find the product of a number and a power of 10 by multiplying or moving the decimal point of the number. For powers with positive exponents, move the decimal point to the right and make the number larger. So let's take a look at this example. 245 times 10 to the third is 245 times 10 times 10 times 10 because of the exponent 3. 10 times 10 times 10 is 1,000, and 245 times 1,000 is 245,000. Just stick with me on this. 1 and 524 thousandths times 10 squared is like multiplying 1 and 524 thousandths times 100, which is going to give you 152 and 4 tenths. If we have 256 thousandths times 10 to the fourth, it's 256 thousandths times 10,000, which is 2,560. Are you starting to see a pattern for this shortcut? If you don't, that's okay. Scientific notation is a way scientists, mathematicians, and economists write very large or very small numbers. It's a shorthand way of writing these numbers. Okay, there's a lot of molecules here in every teaspoon of table sugar, molecules of sucrose. We're going to make this number easier to understand by using scientific notation later. There are two parts to scientific notation: the number between 1 and 10 and the power of 10. So you need a number between 1 and 10 and a power of 10. So 1 and 65 hundredths is a number between 1 and 10, and it's being multiplied by a power of 10. We also have 2 and 4 tenths times 10 to the negative fourth, number between 1 and 10 multiplied by a power of 10. So let's take a look down here. Circle the numbers that are in scientific notation. Remember, you need a number between 1 and 10 multiplied by a power of 10. You can pause and circle, and I'm going to go ahead and review the answers. So 4 and 5 tenths times 10 to the fourth. Is this a number between 1 and 10? Yes. Is it multiplied by a power of 10? Yes. 6 and 78 hundredths, is that a number between 1 and 10? Yes. Multiplied by a power of 10. 8 times 10 to the negative third, number between 1 and 10, multiplied by a power. Yes, even though it's a negative, it's still a power. 12 and 1 tenths times 10 to the seventh. Well, 12 is higher than 10, so this is not written in scientific notation. I'm not going to circle it. 6 times 10 to the third power. Is 6 a number between 1 and 10? Yes. We have it multiplied by a power of 10, so we're going to circle it.
I just didn't want to say anything about your
1 and, wow, that's a really big decimal. 1, 2, 3, 4, 5. This is a number between 1 and 10, barely, times by a power of 10. 9/10 times 10 squared. This is not a number between 1 and 10. We're not going to circle it. 25 and 6/10, not a number between 1 and 10. We aren't going to circle it. 10 hundredths, again, not a number between 1 and 10. 9 and 999 thousandths, yes, that's a number between 1 and 10, and that's why we're going to circle it. So all of these numbers are in scientific notation because they fit the rule. A number between 1 and 10 multiplied by a power of 10. Let's check out the last page. All right, that's a bunch of molecules of sucrose in every teaspoon of table sugar. This number is written in standard form. It's not written in scientific notation because it's a really, really big number. But we're going to change that really big number into scientific notation by using the rules on the other page. So here are the rules. To go backward, we must move the decimal point to create that number between 1 and 10. Now, if we don't see the decimal point, where is it? That's right, it's all the way at the end. So we have to create a number between 1 and 10, which means we're going to go back up here. So what number can we create using these numbers here that would be between 1 and 10? 3.35. And now we have to move this decimal point all the way back to create that number, which means we got to move it all the way there. How many times are we going to have to move that? So we have our times 10, and then I'm going to just skip count here. 3, 6, 9, 12, 15, 18. Wow, 21 times. That's huge. So it becomes 3 and 35 hundredths times 10 to the 21st power. And I think actually reading this number gives me a pretty good idea how big the original number is. And that's what we're trying to do. Plus, we don't want to take up all that space on our paper when we're writing our scientific journals. So now we're going to practice changing from standard form to scientific notation. Remembering standard form, really big number, scientific notation, small number multiplied by a power of 10. Okay, so we are going to change these numbers to scientific notation. I've got too many zeros here. So 1,200, if we don't see the decimal, it is at the end. We need to create a number between 1 and 10, which is 1.2, times 10, 1, 2, 3, to the third. 353,000. Decimals at the end. We need to move it here. 3.53. Got to use all those numbers. Don't just say 3.5. Times 10. 1, 2, 3, 4, 5. To the fifth power. 123. Decimals at the end. Got to move it there. 1.23 times 10. 1, 2. Squared. Now this one is a different one. 8 hundredths. Got to change it to scientific notation. Well, if I move it, the decimal point, it's going to go here, which is going to give me 8 times 10, but I'm moving it the opposite direction. So I moved it twice, but 8 times 10 squared is 800. I want to show that it's 800th. What do I need to do with that exponent? Yep, make it a negative. That's a challenging one. Let's take a look at the last. We're going to change to standard form, which means we're going to make this into a really big number. So we have 2.3 times 10 to the fourth. We're going to move the decimal point 4 places. I ran out of spots. 1, put in some zeros. 2, 3, 4. 2, 3, 4. So we have 23,000. 21 and 9/10 times 10 to the 7th. We need to move the decimal point 7 places. 1, 2, 3, 4, 5, 6. 219 million. And 4 35/100ths times 10 to the 4th, we're going to move the decimal point 4 places. 1, 2. 1, 2, 43,500. So let's see if we're going to find a shortcut with figuring out how many zeros to put on the end so we don't have to do like we did up here and just move all these decimals, these decimal points.